Hi everyone, this is Bhakti Dave, Building Performance Engineer at IESVE. Today I'll be discussing one-click calculations for operational carbon emissions, leveraging automation for efficiency, and data available in the industry for its calculations. This was presented at IBIPSA SimBuild 2024, so I'm recording a video for anyone who missed out on attending the conference in person. Hope you enjoy it. As we all know, greenhouse gas emissions serve as one of the key climate change contributors. Buildings account for approximately 29% of overall emissions, with operational emissions accounting for about 21% of total. Energy use and cost are some of the most commonly used building performance metrics, yet recently, building codes and standards have begun incorporating greenhouse gas emissions. However, the use of hourly rates for electricity remains non-mandatory. Evaluation of greenhouse gas emissions from electricity can be done either using annual rates or hourly rates. Use of annual rates from sources like EPA or Energy Star Portfolio Manager is more common, even though they are known to be less accurate. This is because they make calculations quicker and easier. On the contrary, use of hourly rates from sources like Inwell's Cambium or WattTime, despite being known to be more accurate, isn't as common. That's because of the inherent complexity involved in its evaluation. So the question is whether the accuracy of time of use of emissions from energy provided by hourly rates is worth the complexity involved in its evaluation. We'll explore a few case studies to answer that question. The data here compares annual performance based on emissions and energy cost for two design scenarios for a code house in California. The base case is gas boilers, and the alternate has electric boilers for heating. Now, let's just focus on this graph first. The y-axis has three different performance metrics. The first one, greenhouse gas emissions hourly rates, is calculated using Enroll's hourly rates. Greenhouse gas emissions annual rates is calculated using annual rates from EPA, and energy cost is calculated using tariffs for natural gas and electricity. The performance of the base case, which has gas boilers for heating, is represented by 0% on this graph. The performance of the alternate, which has electric boilers for heating, is represented as a percentage variation from the base case as seen by these blue bars. Now, a lower number or a bar on the left indicates that the alternate with electric boilers has lower emissions or costs compared to the base case with the gas boilers. On the contrary, a higher or a positive number and a bar on the right indicates that electric boilers have higher emissions or cost compared to the base case. Now, for this particular courthouse in California, we can see that the alternate with electric boilers yields about 7% lower greenhouse gas emissions compared to the base case. Now, this is the only metric where electric boilers perform better than the gas boilers, unlike the emissions calculated using annual rates or energy cost. So why is that? This heat map here illustrates 8760 data points, with y-axis representing each hour of the day and x-axis representing each day of the year, although only months are labeled. The colors represent the greenhouse gas emission rates, with purple indicating the lowest emission rate and yellow indicating the highest emission rate. This particular heat map has been developed using Cambium's hourly emission rates for the state of California. Now you can see that emissions are much lower during the daytime, let's say from 7 a.m. to 4 p.m. and in seasons of spring and summer. So overall, hourly rates allow for more precise estimation of greenhouse gas emissions by reflecting for spatial and temporal variations, unlike the annual rates. For the same project and design scenarios, in a project life cycle of about 30 years, the alternate with electric boilers yield significantly lower greenhouse gas emission rates compared to the base case, unlike emissions calculated using annual rates or energy cost. This is because Cambium offers hourly rates for various future scenarios in the U.S. electricity sector until 2050, enabling forward-looking analysis, which also accounts for growing contributions of renewables at grid level over time. Use of hourly rates also has the potential to enhance lead points. This youth center in California was able to get one extra lead point just by using hourly rates for calculating greenhouse gas emissions for baseline and proposed models. So going back to the question on whether the accuracy of time of use emissions from energy provided by hourly rates is worth the complexity involved in its evaluation. We think it's definitely worth it, particularly when automation can be leveraged for streamlining the complex evaluations. I'll walk through some of our Python-based tools that I've used for analysis of the case studies presented here and for the graphics thereof. One of our tools, called Greenhouse Gas Emissions Summary Report, offers dynamic insights into various hourly versus annual metrics, energy versus emission profile, and more, all with just one click. We also have another tool that produces report for LEED's alternate energy performance metric pilot credit. This report provides savings for two best performing metrics amongst energy use, cost, greenhouse gas emissions, and TDV for projects located in California without requiring any manual calculations from the user. To gain value from more such tools, please visit bemtoolbox.com. Our energy results reporting module is now also available on IES's content store. Here's a shout out to my team members who contributed in development of such valuable tools. To conclude, to aid in building decarbonization effort, we think it is crucial to assess buildings' performance holistically, which not only accounts for energy use and cost, but also greenhouse gas emissions. Our team uses Cambium's hourly data to support electrification, as they accurately reflect real-time emissions by incorporating spatial and temporal variation, as well as offer hourly data sets for various future scenarios in the U.S. electricity sector until 2050. If you guys are interested in learning more on how you can leverage automation on your project, please feel free to reach out to us. Thanks for watching the video.